In this lesson, we're going to look at more with finding exact angle measures um, and looking at angles that are bigger than 90 degrees. So there's a couple of things that we have to look at, and the first thing is the unit circle. So basically what the unit circle is, it's a circle where the radius is 1 unit, which is why it's called the unit circle. So what that means is this length from the center out to any point on the circle is 1. So this coordinate here would be 1 comma 0. This coordinate would be 0 comma 1, negative 1 comma 0, and this one would be 0, negative 1. And this is obviously the point 0, 0. So basically the importance of this unit circle is the fact that these points here are the cosine, so the x value is the cosine of whatever the angle is, and then the y value is the sine of whatever the angle is. So remember theta, this symbol here, is just a symbol that we commonly use for angle measures. It's just a variable is all it is. So basically what this is saying is this is our x and this is our y value for any point on the unit circle. And theta is an angle. So another important thing to note here is that when we're talking about tangent, which we'll look at too at the bottom in the chart, tan is equal to sine of theta over cosine of theta. So what that means in terms of the unit circle is tangent of whatever the angle is equal to y over x, or y divided by x. So when I'm looking at this, these numbers here stand for cosine or sine of whatever the angle is. So the next important thing is, what angle is this? So when we started a circle and we're talking about the degree or the angle measure, we always start at this point here. So this is going to be our 0 degrees. And then we always move around the circle counterclockwise. That's to measure positive angles. So this would be 0 degrees. This represents 90 degrees, right? Because we have a right angle here. This would be 180 degrees because we have a straight line, or we're going around half of a circle. Then we have another 90, so 180 plus 90 is going to give me 270. And then 270 plus 90 will get me my 360. So if you start at 0, so if I'm at this point, cosine of 0 is 1, sine of 0 is 0. That's what this is saying. Cosine of 90 equals 0, sine of 90 equals 1. So these degree measures are what are going to give us this cosine of whatever the angle is and sine of whatever the angle is. Keep in mind, you could, well, there are points if you fill them in. Like I could have a 30-degree marking, which would be over here. There's points for that, but for the unit circle, I like to just remember these um, as my basics, because these will give you your 4 points that come up often. And then I have other ways to remember, like the 30, the 60, the 45-degree angles. The whole purpose of this is really just to look at exact angle measures. So instead of just typing in sine of 45 into your calculator, our goal is to be able to come up with the exact value. So leaving it as a radical or a fraction instead of just putting it into our calculator and getting a rounded decimal. So there's the unit circle. The unit circle is convenient when you're trying to find cosine, sine, or tangent of 0, 90, 180, 270, or 360. For angles like 45, 45, or 30, 45 or 30, 60, we use these special right triangles. So we have a 45, 45, 90 right triangle, which is basically just saying you have a 90-degree angle, and the other two angles are 45 degrees, which means that this triangle is isosceles, so it has two congruent legs, and the ratio of the sides for this triangle are always going to be in a 1 to radical 2 ratio. So this is one way to remember it. It's basically a portion off of the unit circle. Um, But another way to remember it, which will make it a little bit easier for rationalizing, is to remember it this way here. So if I have my right triangle, I have 45, 45. I could actually remember this as, so basically if I multiply everything by radical 2, I end up with radical 2, radical 2. If I multiply that by radical 2, I end up with 2. So this is equivalent to this because it still has the same ratio. It's just this second version makes it easier when we fill out the chart in the bottom of the page. And then the 30, 60, 90 triangle. So this is my 30 degree, 90 degree, 60 degree. When I'm looking at this, the 30, 60, 90 is in the ratio of 1 radical 3 to 2. Now, keep in mind in a right triangle, the hypotenuse is the longest side. So the longest side should be across from the largest angle. So 90 degrees is the largest angle. 2 is the largest side. Radical 3, if you put it in your calculator, it's like 1.7. So that's why it's the middle size side. So 60 degrees is the middle size angle. So across from it is the middle sized side. And then 30 is the smallest angle. So across from it's the smallest side. So that's another one. So then the whole purpose of these special right triangles is to be able to find more angle measures. So we have the unit circle to figure out 0 degree, 90 degree, 180, 360, 270. But if we have some other angles such as 30 degrees, 60 degrees, or 45 degrees, we're going to be using these special right triangles. Because again, the whole idea here is to have our answers be as exact as possible, meaning we don't want to just throw them into a calculator anymore and get decimals. We want to use exact answers. So anytime we can use these 30, 60, 45 triangles or measurements, we want to be able to do that. So basically, in order to interpret these triangles, we can use our SOHCAHTOA because these are right triangles. And remember, whenever you have right triangles, you can use SOHCAHTOA. So if I'm looking at these examples and I want to fill in this chart, first thing here is a row for radians. So basically, when we are talking about trig, we have two measures. We have degree and we have what's called radians. Um, radians, so pi is basically how we use, well, when we talk about radians, um, pi is always going to be equal to 180 degrees. So that's kind of the relationship here. And when we're looking at writing our answers in radians, really we're looking at writing our answers with a pi in there. Um, so if we look, 0 degrees is just going to be 0 pi because it's still going to equal 0. And then for these other ones, I'm just going to write them in and then we'll talk about them in the next page or so. So we have 30 degrees is pi over 6, 45 degrees is pi over 4, pi over 3, pi over 2, 180, 3 pi over 2, and then 2 pi. Basically, if you know that pi and 180 are equal to each other, or 180 degrees is equal to pi radians, basically what that means is I kind of think of 180 degrees equaling pi. So if you want to convert everything else, well, 360, there's two 180s in 360, so that's why it's 2 pi. If you're thinking about 90 degrees, there's half of 180 is 90, so half of this pi is 90 degrees. 180 to 60, well, if I divide this by 180 divided by 3 gives me 60, so I take pi and I divide it by 3. So that's really the pattern. But we'll talk more about how we can convert between degrees and radians in a little bit. So let's go back to looking at finding these exact angle measurements. So if I'm talking about sine, cosine, and tangent, I want to be able to fill in whatever I can. So like 0, 90, 180, 270, and 360, those are going to come from our unit circle. So if you look up at the unit circle, if I'm filling in sine of 0 is going to be 0 because I'm looking at the y values. Sine of 90 is going to be 1. Sine of 180 is going to be 0. Sine of 270 is going to be -1. Sine of 360 is going to be 0. So let's go ahead and fill that in. So we have 0, we have 1, 0, -1, and 0. So I just get those from the y values up above. For cosine, we can do the same thing, except for it's going to be the x values. So it's going to be 1, 0, -1, 0. So we have 1, 0, -1, 0, and 1. So I look at the x values for each of these degrees. And then for tangent, remember tangent is just equal to sine of theta divided by cosine of theta. So 0 divided by 1, so really just divide these. 0 divided by 1 is 0. 1 divided by 0 is undefined. 0 divided by -1 is 0. -1 divided by 0 is undefined. 0 divided by 1 is 0. Okay, so then let's go in and fill in these other measurements. So the 30, the 45, and 60. So this is where we're going to use SOHCAHTOA. So if we're looking at sine of 30, I'm going to go to this triangle, and remember sine is opposite over hypotenuse. So I go to the 30. The opposite is going to be 1. The hypotenuse is going to be 2. So sine of 30 is equal to 1/2 in any single triangle. Sine of 45, we go to this one. Pick any one of the 45s, doesn't matter. And we go opposite over hypotenuse. So if I do sine of 45 in this one as opposite over hypotenuse, what happens is you get a radical in the denominator and then you have to rationalize. So if you remember, rationalizing means you multiply the top and bottom by a radical, by whatever the radical is in the denominator. So this becomes radical 2, and then in the bottom it becomes 2. But if you use this triangle right here instead, if you look at sine of 45, opposite is radical 2 over hypotenuse is 2. Basically, it gets you this answer, but it gets it to you quicker because we've already taken care of the rationalizing piece when we multiplied everything by radical 2 from the original special right triangle. So either one works, but this is definitely the shortcut so you don't have to rationalize your answers. And then we do the next one, sine of 60. So start at 60. Opposite 60 is radical 3 over hypotenuse. Then we do cosine. So cosine of 30 is going to be adjacent, radical 3 over hypotenuse. So notice that these flip. And then we have cosine of 45. So cosine of 45 is adjacent over hypotenuse. And then sine or cosine of 60 adjacent over hypotenuse, so 1 over 2. So these flip because the angles are complementary. They add to 90, so that's why those are doing that. And then to get the tangent piece, you're dividing these. So you do 1/2. So if I'm looking at, let's say, tan of 30, I do 1/2 divided by radical 3 over 2. And if you remember when you divide fractions, you keep the first one, change the sign of multiplication, flip the bottom one. So then the 2's cancel, I'm left with 1 radical 3. But then I have to rationalize that. So multiply the top and bottom by radical 3. We get radical 3 over 3 for that one. This one, if I take something and I divide it by itself, we're going to be left with a 1. And then this other one here, tan of 60, we have radical 3 over 2 divided by 1/2. So this is keep, change, flip. Those cancel. We're left with just the square root of 3. Square root of 3 over 1, which is just the square root of 3. So there's our chart. So this chart should be very helpful for you because basically what this chart is doing is it's giving us all of these common angles that we can find exact values for. Now, there's other angles that we could find exact values for, but these are the most common, and these are the ones that you really need to be able to come up with. So, for example, if you put sine of 60 in your calculator, you're going to get a decimal. But we no longer want that decimal. We would want to leave it as radical 3 over 2. So this chart you should be able to create, especially because you can come up with it using the first two things, the unit circle and using the special right triangles. So it's something that you should be able to reproduce either by memorizing or by just doing what we just did, coming up with the whole process. There are some patterns that you can remember with these. If you look at the top here, it goes 0, 1, 2, 3. And then for cosine, it's the opposite. So it goes down instead. It starts up at 1, and then it goes 3, 2, 1, 0. So just some different patterns you can look at, but really you should just know the special right triangles, know the unit circle at those points, and you should be good to go. So if we look at the next page is really going to be using these angles. How can we use these angles, the 30, 60, and 90, to come up with more measures? So what we have to be able to do is we have to be able to take angles that are bigger than 90 degrees and find their reference angle, what's called their reference angle. So when we talk about reference angles, I think of it as the bow tie. So basically in the first quadrant here, so if we label our quadrants 1, 2, 3, and 4. Remember when you label quadrants, you label them in the C shape. The reference angles in quadrant 1 are going to come out anywhere off of this axis. And then the reference angles down below have to come off of this axis. And same with in these. So basically what this ends up being is it kind of looks like a bow tie. So reference angles always have to touch the horizontal axis. So basically when we talk about getting the reference angle, we're trying to get an acute angle. Hopefully one of them's 30, 45, or 60 so that we can easily find the measure. But we are always talking about the angles that are touching the horizontal axis. So they're always coming off of that. So let's look at how to find a reference angle. So if I have the angle 210, basically this is your 0 degrees, this is 90, 180, 270, and then back to 360. And you can keep going around. But you always start here and you always go counterclockwise. So if I'm looking at 210, I would be starting here. And I'd be going past 180 somewhere down in here. And then what I would do is I would draw in this angle. So this angle here represents 210 degrees. So this little piece here is called the reference angle. So our goal would be to find that reference angle. So it's in the third quadrant, 210. And the reference angle for this is what we want to be able to find. So the reference angle, if I want to find, if this whole thing's 210, and I want to find just this portion, I have to subtract off what I don't want, which is the 180 degrees. Because this section up here is 180. So what I do is I take 210, and I'm going to subtract 180, and that leaves me with a 30-degree reference angle. So this is my reference angle. 315 is the next one. So 315, I'm going to go start, and I'm going to go all the way around past 270, somewhere in here. So this would be my reference angle, because remember the reference angle always comes off of the x-axis. So I'm in the fourth quadrant for this. And in order to find the reference angle, I would do the entire circle, 360, minus the section I don't want, which is the 315. And that'll leave me with the reference angle. So I'm going to do 360 minus 315, and we get 45 degrees. So the reference angle is 45. So basically you can kind of start to see the pattern here. Some of you might like just thinking about it and what makes sense, but there are formulas. So pretty much if you have something in the third quadrant, you're going to do whatever the angle is, and you have to subtract 180 off of it, because you basically subtract off this semicircle. So I'm going to say that the formula for the third quadrant is to take the angle and to subtract off 180. Where if the angle ends up in the fourth quadrant, you have to take the entire circle and subtract off the angle you don't want, and then you'll be left with the reference angle. So for this one, you do 360 minus your angle that was given to you. So then let's look at another one. If I want to look at 150, 150 is going to end somewhere in the second quadrant. So if this is 150, if I want to find my reference angle for this, I would have to do 180, which is this whole semicircle, and I would subtract off 150, and that would leave me with this little portion. So if it's in the second quadrant, I would be doing 180 minus 150. So start with the whole piece, subtract off what you don't want, and that would get you your reference angle of 30. So if it's in the second quadrant, you're going to start with 180, and you're going to subtract off the angle, because that's going to be the piece you don't want. And as you can imagine, if anything's in the first quadrant, it's going to be, the reference angle is going to be however many degrees that is. So for example, if I had a 20-degree angle and I were to draw it, it would look something like this. That 20 degrees is the reference angle. It's touching the x-axis. So in the first quadrant, the reference angle is the angle, because its reference angles are the acute angles that are touching this axis, this horizontal axis. So let's just finish this chart up. So if we have 250, so 250 here is going to go down all the way into the third quadrant. So 250 is going into the third quadrant. I would have to do, I don't want to include all of this, so I would have to do 250 minus the section I don't want, which is the 180. I don't want that, and I want to be left with my reference angle. So I'm going to do 250 minus 180, and that's going to get me my reference angle of 70. Then we have the next one, 140. So 140 will end up over here. So let's do it so that you can actually see it. So 140 would be somewhere over here, right before 180. So this would be my reference angle. So I'm going to do 180. Ends up in the second quadrant. I'm going to do 180 minus the part I don't want, which is 140. Leaves me with my reference angle of 40. 330 is the next one. So let's look at that one. So this is getting crowded, so let me get rid of some of this stuff here. So this is 90. Okay, so if I'm looking at the next one, which is 330, I start here, I go all the way around, I gotta go past 270, somewhere in here. So this is 330. The reference angle is this little section here. So I have to figure out how many degrees are in there. So I do 360 the whole circle minus the section I don't want, which is 330, and that'll tell me how much I'm left with. So you'd be left with 30 degrees as your reference angle. So essentially for the fourth quadrant, 360 minus what we don't want, and then you're left with your reference angle. Again, you could use these formulas though. And then the last one here, 260. So if I go around to 260, it'll be just short of 270. And your reference angle is always the angle that touches the horizontal axis. So this angle is going to be my 260. So if I want to find the reference angle, I'm going to take 260, but then I'm going to subtract off the 180, the piece that I don't want. So if it's in the third quadrant, I'm going to do 260 minus the piece I don't want, which is 180, and I'm left with 80 as my reference angle. So that is going to be it for the first part here. So we're looking at our reference angle, and then in the next lesson we're going to talk about how are these reference angles actually going to be helpful. So how are we going to use these to be able to find exact values of angles that are acute as well as angles that are obtuse. And we will also look at converting between radians and degrees as well.